Alright, our last objective for this unit is that you graph log functions based on their key features. As we do this, I want you to keep in mind that a log function is an exponential function that's just sideways. So it's the same shape, a lot of the same properties apply. So if you can remember what you did last unit for exponential functions, a lot of that still applies. So we've got log base 5 of x in our first example. Your asymptote is normally x equals 0. That's a vertical line. And your initial point is normally 1, 0. These things only change if something has been shifted. And you notice here there's no horizontal or vertical shifts. The next example will have both. But if there's nothing, you just start with these. So my asymptote is at x equals 0. So in my bad handwriting, I'm going to put a vertical line at x equals 0. This is the first time we've dealt with vertical asymptotes. And our initial point is at 1, 0. So that's on the x-axis right there. All right. Now, hopefully you remember the exponents. You would take the distance and you would multiply it by the base, or by the multiplier. In this case, we do the same thing. We look at the base and we multiply it by that number. So right here, the distance is 1. 1 times 5 means that the next distance is going to be 5. Now, we're going sideways instead of up and down because everything is sideways here. So, next point up is going to be 1, 2, 3, 4, 5 over. And if I had space, the next one would be 25 over, because that's 5 times 5, but I don't. And you honestly normally won't here. So, we're basically done. We're going to connect this. Exponential functions get close to the asymptote on one side and sweep away on the other side. So log functions do the same thing, except sideways. So this is getting close to the asymptote as it goes down. The calculator often will not show you that it keeps going down. It looks like it just stops right around here, but you have to know it's getting closer to the asymptote. Our next example, we've got log base 3 of x plus 1 minus 4. So the plus 1 we know means left 1. And the minus 4 we know means down 4. And I'm going to write this again. Remember how our asymptote started at x equals 0? Well, if that moves to the left, now it's at x equals negative 1. So I deliberately wrote that just so you guys remember that we start here and then we think about what this does to it. And our initial point also is going to change, but if it started at 1, 0, and 1, 0 goes left 1 and down 4, now we're at this point. We're at 0, negative 4. So hopefully you see what happened here. We still thought about what it would be if there hadn't been a shift, and then we considered what that shift did to these things. So my asymptote is that x is equal to negative 1, so that's a little bit to the left. And then our initial point is at 0, negative 4, so that's down on the y-axis. And then we just use the base to get the next point. So if this is 1, the next point is going to be 3 because 1 times 3 is 3. Again, it's the same base as the exponent. Now, I'm not going to have space for it, but the next point will be 9 because 3 times 3 is 9, so that would be like a little bit off the graph here. And then when you connect it, it should kind of look like the last one, right? A sideways exponential function. It sweeps away from the asymptote as you move up, and then it gets closer to the asymptote as you move down. So same shape, just sideways. And that is it. This is about as complicated as these will get. So we have now graphed logarithmic functions based on their key features.